Now the frequency distribution of the phase plaque. This is different kind of the procedures we can use for the frequency distribution of the phase plaques. First of all, how much things we need, that what we think, about 33 samples are enough for these experiments. And then the dilution, the phase dilution is very important. 0.1 ml of the dilution phase preparations will be used for this frequency distribution experiments. And then the plate counts will be of course very important. Here you can see just in the table the PR experimental and the PR in the calculations. If the 0 plaques are in the plates, first of all we just see that plates, how many plates are there, 0, 5, 13 and 14 plaques, and then the plates, and then the plaques, the number of the plaques which are particularly present on those plates, and then the PR, and then the calculated, and then the experimental. First of all, if we have the plaques which are 0 on the 13 plates, then the experimental PR will be the 0.394 and then the calculated will be 0.441. Similarly, you can see that plaques number will be 0, 1, 2, 3 and 4. However, the number of plates were different. With the increasing the number of plaques, the plates are different quite here. One plaque is on the 14 plates. Similarly, the 2 plaques are on the 5 plates. And then the 3 plaques are appeared on plate 1, on the 1 plate. So these are the number of plates, and then the 4 plaques on the 0. There will be the, of course, experimentally we have seen the 4 plaques and then the 0. If we calculate that formula, it will be specifically 0.008. And then the experimental, if we make it equal, if we make it cumulated, it will be 1.002, and then it is totally the 1. It is the frequency distribution. And now let us write the different probabilities, or we can say the different, and the better word will be the, let us calculate different probabilities of having more than 0 or more than 1. The probabilities are more than 2 particles having the more than 1 particles of 2 particles of the phase distribution. We can see it, the probabilities, and we can see it at how much the infectious units or the frequency distribution of the phase were present in that specific kind of the samples. We see it here. If the probability is the more than 0, then the formula will be used. It is here, and then you can calculate it by yourself with your own experiment which you are working with that laboratory, and you can see that how much weight viruses frequency, the frequency distribution is done if the probability of the viruses or the probability of the particles is less than 0. Similarly, if you are working with the probability of working with the samples which is more than 1, then you can use this formula, and then you can see it. And similarly, there is one more, probability is more than 2, then you will use it here, and you can calculate it by yourself, the frequency distribution. Here in the graph presentation, you can see it, probability of the working with those infectious units and with those particles per sample. Here the probabilities of more than 1, 2, 3, 4, and then the same formula which we have already applied, you can see, and you can calculate the frequency distributions accordingly. However, there are some more factors which need to be determined or which need to be taken into account when we are working with these frequency distributions. Theoretical dependence of the frequency on of the positive samples or the concentrations of the particles in an inoculum. Theoretically, it is very important that if the number of the samples or number of the inoculum has more viruses, of course, similarly, it will cause the clinical signs more rapidly, and it will be dependent on that frequency of the positive samples. If the inoculum has less particles of the viruses, then of course it should have less clinical signs, and similarly less concentrations of the particles should be appeared in that specific kind of the samples. The graph which we have already seen in the last slides, they have the 4 curves 1, 2, 3 and 4. They will be represented by the expected frequencies which we have already probabilities. We have seen the probability of having the particles 1, less than 1, more than 1, or more than 2, more than 3, or more than 4. Similarly, the curves which are shown in the last graph, which we can see the probability for more than 1, 2, 3 or 4. And similarly we can use the formula which we already studied to see the frequency distributions accordingly.